All right, to start our proportional reasoning unit, we're going to start with something very simple, and that's pretty much a review of last year, and that is what's called a ratio and a rate, and then we'll get into unit rates. So to start off with, you have to know the terminology and you got to know the difference. Ratio is when you compare two quantities with different units, whereas the rate compares two quantities with the same unit, and a unit rate is a rate that compares the second quantity to one. So a ratio is going to be something like miles per hour because you're comparing miles and hours. Therefore, two different units. If you're comparing two quantities with the same units, boys to girls is considered a rate because you're dealing with people, basically. Okay, and then the third one's going to be unit rate, and you're saying how many miles can I do in 1 hour? How long does it take to bake one cookie? How much is it going to cost for one movie? Those kinds of things. Now, to calculate a unit rate, you have to divide the first by the second. And then the phrase that I kind of came up with to help students with unit rates is that money always comes first. Always. Every time, whenever you are writing a ratio or a rate, money is always your numerator. Every time. You're never asking how much can I get for $1? You're wanting to know how much is it going to cost me to buy one of something. Now, when it comes to dealing with better buys or the best buy, you've got to be able to compare things that are equal. And we do this by using a unit rate. So whenever you're asked, which is the better buy for me, which is going to be the best for me to buy for the most bang for my buck kind of thing, you're going to deal with unit rates. Going back to money always comes first. And then unit rates basically tell you I can get more for the less amount of money. What's the most that I can get for spending the smallest amount of money? So let's take this from the beginning. Question number 1, straightforward, says find the unit rate. Well, we are given that 7 ounces of crackers cost $1.19. So we know that money always comes first. And then the other unit in this problem is ounces. So we know that we can get for $1.19, we can get 7 ounces. Notice that when I wrote my ratio, or my rate, I put the units with it. This is going to be a huge thing. Having the rate or having the units written out to the side, it's going to be like a little graphic organizer for determining where numbers go. As you go on in this unit, it's going to become extremely important. So go ahead while we're doing this right now, and it's pretty easy and straightforward and things you remember. Do this part just to keep things easier for you in the end. So we know that $1.19 can get us 7 ounces. To figure out how much 1 ounce would be, we have to divide by 7, because 7 divided by 7 is 1. What we do to the bottom, we do to the top. So we divide $1.19 by 7. And using the calculator, we find out that that's 17 cents. This means that for 17 cents, we get 1 ounce. And that's our unit rate. So for each ounce, you're going to pay 17 cents. Now, number 2 says 1 pizza can feed 4 people. So we have 4 people. Again, notice my units. Can eat off of 1 pizza. And that's a unit rate because 1 is in the denominator. And I want to know if I have 16 people, how many pizzas? Well, how are you going to get from 4 to 16? Using multiplication, only multiplication or division, we can multiply by 4. But what we do to the top, we got to do in the bottom. So therefore, how many pizzas are we going to need to feed 16 people? We would say 1 pizza times 4 would tell us that 4 pizzas feed 16 people. All right. Now, that's a way we can use the unit rate. In the first problem, in the first example, we calculated unit rate. In the second example, we used the unit rate. In this third example, we're going to take it up a notch with a slightly more difficult problem for unit rates. John can paint 1/8 of a wall in 11 minutes. How long will it take him to paint a room with 3 walls? Let's think for a minute. If he can do 1/8 of a wall in 11 minutes. Notice the units. You can go about this 2 ways. If he were to double it, meaning he were to multiply by 2, or he were to add another 1/8, that would be like saying you could do 2/8 of a wall in 22 minutes. And then we could keep going and say we can do 3/8 of a wall in 33 minutes. Right? And we could keep going and going and going, right? Until we got up. Or we can think of it this way. If we can do in 11 minutes, we can do 1/8 of a wall. Hopefully you know from fractions that he can do, that's 11 minutes. Well, you can think of it as it takes 1, 2, 3, 4, 5, 6, 7, 8 eighths. It takes 8 of those sections to make one whole wall. So we could multiply by 8, because by doing that, that's going to tell us that it's going to take him 88 minutes to do one wall. Now, you had enough space, you could have counted up by 8s and just kept adding 11 minutes over and over. But this just goes a little bit quicker. Now, it doesn't ask him how long it takes him to do one wall. It says 3 walls. So that means we have to do what one wall is, and we have to multiply by 3, because that's going to give us 3 walls. So for 3 walls, using our calculators, it's going to take us 264 minutes to do 3 walls. All right, now let's kind of address something here. It asked us how long, meaning we could have done it in minutes the way we did, or you can convert this to hours. 2 ways to convert this to hours. First way is to say you can take off 60 minutes until you get there, or you can do division, either way. But if the problem doesn't ask you to specifically convert it into hours and minutes, don't go that extra mile. Again, we want to remove that opportunity for carelessness. So you're more than welcome to convert it to hours if you'd like, but it was not asking us to, so we don't need to. Okay, now that we've talked about how to find a unit rate and how to use a unit rate to figure out a direct amount or an indirect amount, the way we did with the pizza and the painting the walls, now we're going to get into better buys. So, for the first one, it says a 3-pound package of ground beef is $7.80. A 1/2 pound package is $1.28. What is the difference in cost per pound between the larger and smaller packages of beef? What we first have to do is figure out that the large package of beef, this is large, is $7.80, and we know it's going on top because it's money, and that it is 3 pounds. So we want to know for 1 pound, how much is there? To get to 1 pound, we have to divide both top and bottom, or both bottom and top, by 3. It's your denominator. So we say $7.80 divided by 3, and that gives us $2.60. Now we have to do the small one, which is $1.28 for half a pound. You can think of this as one of two ways. You can think of it as I have half a pound, so I'm going to add a half a pound with it. So it's like half a pound and half a pound makes 1 pound, so 1.28 plus 1.28. Or we can come in and divide by a half. And 1.28 divided by a half is going to be 2.56. So $2.56 for 1 pound. So it asked us not what the unit rate was for either the large or smaller. We were asked, what is the difference? Please make sure you are answering the questions. To calculate the difference, difference means we need to subtract. So we take $2.60 minus $2.56 to give us that it is a difference of 4 cents. Now on to the final one. This is an example of a real life problem that anybody who goes shopping encounters regularly. And what it basically says is you can buy soap, and I'm going with its dish detergent, even though it doesn't really say. And it says, which is the best buy? So I like to call this the Target, Walmart, Costco problem, and here is why. You can go to Target and get a regular bottle of dish detergent for $1.34. Or you can go to Walmart and get the family size, because it's going to be you and your parents and your siblings and your grandparents and maybe an aunt or uncle coming over, and you're going to be doing their dishes. So you need the family size, and you can get that for $3.25 when it has 28 ounces. Or you can go to Costco and you can get the economy size, because it's going to be you and about 10 of your neighbors, families all coming over, and everybody's going to have a ton of dishes that need to be washed. And so that's 40 fluid ounces, and so that's going to cost you $4.08. And so it wants to know which is going to be the better buy for you. Which one are you going to get the most for your money? In order to do this, we have to calculate the unit price for each of these. So we have $1.34 for the regular divided by the 12 ounces. And $1.34 divided by 12 is going to give us about, we use the squiggles for about, 0.112. Oh, sorry, 1. And since we're talking about money, we know that third one is going to make that second one stay. So we get 11 cents for 1 ounce. Now we move into the family brand, which is $3.25 for 28 ounces. So we divide both by 28. And $3.25 divided by 28 is approximately, so squiggles for approximately, 0.116. So we say that 6 makes the 1 go up, so it becomes approximately 12 cents for 1 ounce. Now we have the economy size, where you're going to have half the neighborhood coming over. You got to wash dishes, which is $4.08 for 40 ounces. And we divide both by 40, because we're trying to get to 1 ounce. So we get 4.08 divided by 40 is equal to 0.102, and the 2 makes the 0 stay the same. So we end up with about 10 cents for 1 ounce. When we look at these, we should note that I can pay 10 cents an ounce, 11 cents an ounce, or 12 cents an ounce. Even though the overall cost is more on some of these, or the cost of the bottles are different, the size of the bottles are different. And so when we take a look at this, we note that the regular size, I'm going to pay 11 cents for each ounce. The family size, I'm going to pay 12 cents for each ounce. Or the economy size, I'm going to pay 10 cents for each ounce. If I am going out shopping, I want to get the most for the least amount of money. No one goes shopping and says, I want to spend all this money. The answer is the economy, because you're paying the smallest amount for each ounce in the bottle.